In this lesson, we want to talk about basic circuits and Ohm's law. Ohm's law is the relationship among the current, electromotive force, and the resistance in any electrical circuit. It's I equals E divided by R. I represents the current as amperage, E represents the electromotive force in volts, and R represents the resistance in ohms. To find voltage, you multiply I times R. To find current, you divide E by R. And to find resistance, you divide E by I. There's few examples of Ohm's law I'd like to go through. What is the current in the circuit shown below? This is a series circuit. One load, one path. E is 120 volts. R is 220 ohms. So E divided by R is 120 divided by 20, which is 6. So the current is 6 amps. An electrical circuit we know is a complete path for current to flow. When the circuit is complete, it's closed. When the circuit flow is interrupted, it's open. All electrical circuits must have a complete path for electrons to flow, a source of electrons, and some device that requires electrical operation or energy for its operation. In this case, we have a generator and one light bulb and a switch and the wiring, which is the path. A series circuit where it allows switches and control devices to control one or more load. It's the simplest and easiest circuit to understand because it's one path. An example of a series circuit is the old style Christmas tree lights. One bulb goes out, the remaining bulbs also go out. In this case, we have a series circuit with heating elements. They're all in series, one path for electrical to flow. The calculations for a series circuit are also pretty similar because there's only one path for current to flow. The current drawn in a series circuit is the same through the entire circuit. No matter where you measure the current, it's going to be the same. The total resistance in a series circuit is the sum of all resistances in the circuit. So R total equals R1 plus R2 plus R3, and however many loads you have, add all the resistances. The voltage in a series circuit is completely used by all the loads in the circuit. The voltage of the series circuit may change through each load. That's why we don't have very many series circuits in HVAC for loads. The change is called voltage drop. The voltage drop across each load is the amount of voltage used or lost through any load or conductor in the process of moving the current. The sum of the voltage drops of any part of a series circuit is equal to the voltage being applied to the circuit. The voltage drops all add up. So, for example, in the circuit below, find the total resistance and the voltage drop for each element and the current for the circuit. First, find the total resistance of the circuit. So we add all our resistances, 5 plus 20 plus 35 plus 50. The total resistance is 110 ohms. Next, find the total amperage draw of the circuit. The amperage draw of the circuit can be determined using Ohm's law. I equals E divided by R. So you have 120 divided by 110 ohms. So the total amperage of the circuit is 1.09. Now remember, the amperage of this circuit is a constant throughout the entire circuit. Now, use that amperage and find the voltage drop across each element in the circuit. The voltage drop across each element in the circuit can be determined by rewriting Ohm's law to E equals I times R. For the 5 ohm resistor, the voltage drop would be the 1.09 amps times 5 ohms, which would be 5.45 volts. For the 20 ohm resistor, the voltage drop would be 109 times 20, 21.8 volts. For the 50 ohm resistor, 1.09 times 50, which is 54.5 volts. The 50 ohm resistor, the voltage drop would be 1.09 times 35, so the voltage is 38.15 volts. In a parallel circuit, there's more than one path for electrons to flow. Electronic devices are arranged in these circuits so that each is connected to a supply voltage conductor. Parallel circuits are the most common in the industry because all devices operate at the line voltage. Examples of a parallel circuit is the standard wiring in your house. You don't want one switch or one light to control every light in the house. An example of a parallel circuit is found here. You have a generator and a switch and 3 loads that are all receiving source voltage. No current has to go through another load to get to a second load. The current drawn in a parallel circuit is determined for each part of the circuit depending on the resistance of that portion of the circuit. The total current draw is the entire parallel circuit, is the sum of the currents in the individual sections. In other words, all the amperages add. The resistance of a parallel circuit gets smaller as more resistance are added to the circuit. So the resistance is always less than the lowest resistance. The total resistance of a parallel circuit cannot be obtained by taking the sum of all resistances. The resistance for 2 resistors in a parallel circuit can be obtained by using the formula R1 times R2 and divide that by R1 plus R2. If you have 3 or more resistors, you have to use 1 over RT equals 1 over R1 plus 1 over R2, etc. The voltage drop in a parallel circuit is at the line voltage being supplied to the load. In this example, we want to calculate the total resistance of the circuit, the total current draw of the circuit, and the current draw for each resistor. First, we have to calculate the current draw for each individual load. The current draw for each individual resistor can be found using Ohm's law, I equals E divided by R. For the 35 ohm resistor, we know that it's getting source voltage at 120 volts. We divide that by 35.7 ohms, which is 3.36 amps. For the 15.5 ohm resistor, the current draw would be 120 divided by 15.5, which is 7.74 amps. Now, we determine the total resistance for the circuit. We can either, in this case, take your total amperage, which is the 2 amperage added up, and divide it into the voltage, or we can use R1 times R2 over R1 plus R2. So 15.5 times 35.7 divided by 15.5 plus 35.7. So our total resistance are RT equals 10.8 ohms. Then to determine the total current draw, we have our voltage, which is 120. We have our ohms, our total ohms for the circuit, which is 10.8. Divide those, 11.11 amps. So in this case, now we can add to this. This is called a complex circuit, also known as series parallel circuits. A series parallel circuit is a combination circuit containing loads in both series and parallels. Complex circuits are extremely widely used in a lot of the control circuits in the industry today. To solve a complex circuit, start with a small simple chunk of the circuit that you know how to work. Either use series or all parallel. Keep redrawing the circuits each step as it simplifies.